Hey, today we're going to talk about half-lives. And half-lives are incredibly important in the world of nuclear chemistry, and we are doing a project right now in nuclear chemistry, um, because they let us know how much of an isotope remains after a certain period of time. So let's first off start by defining half-life. Now, half-life does have a symbol. Half-life has the symbol of T1 half. Sometimes it's written T1 half. They mean the same thing, or half-life. And the definition, and you should write this down, is the amount of time, time being the trick here, the amount of time it takes for half of an isotope to decay into new products. Half of an isotope to decay into new products. Okay, and we've been talking about alpha decay and beta decay, and this is what we're talking about. These radioisotopes are able to emit radioactivity, and they are able to decay into something new by giving off that radioactivity. Okay, I want to give you a couple of examples here. First off, we have an example of Rn-222. It's going to tell us that Rn-222 has a half-life of 3.8 days. So let's just give you kind of an example of what we're talking about here. Let's say we start off with a sample of Rn-222 and we have 10 grams. And after 3.8 days, which is one half-life, we would then have 5 grams remaining, and 5 grams of it would be something completely new. That is what we're talking about with half-life. And then let's say after another half-life, the 5 grams that were remaining will be decayed into half of the amount, and so on and so forth. And that's really what we're talking about. Half remains, half decays into something new. Now, some elements such as Rn, have a very short half-life. 3.8 days is relatively short. Uranium-235, which is the main component in nuclear reactors, has a half-life of 7.0 times 10 to the 8th year, meaning 7.0 times 10, 8 times, which is a very, very large number. And that's why we talk about this with respect to our project. Uranium has a very long half-life and stays around for a very long time. Now, you're going to be expected to know, your goal today is to know how to do sample problems, how to calculate half-lives and percentages. That's our big goal today, how to calculate. So let's go ahead and do a problem here, and you should copy this down. Okay, so this problem, we have Mn, manganese 56, and they give us some other information. So what we're going to do is this is a two-step problem. First thing that we're going to do, I'm going to scooch this down a little bit to get this out of the way. These type of problems are, like I said, two-step problems. The first thing we want to do is we want to find the number of half-lives. How many half-lives has this radioactive particle undergone? And so the way we do this is we're going to take the time elapsed and we're going to divide it by its half-life. Okay, so I'm going to look at this problem. It says Mn56 is a half-life of 2.6 hours. Okay, that's an important thing. That's its half-life. And what mass of a 1 gram sample remains after 10.4 hours? There's another important piece. So the time elapsed is the total time that has occurred. So that's going to be our 10.4 hours. So 10.4 hours is our time elapsed. And then we're going to divide it by our half-life, which in this problem it told us was 2.6. And we divide those two, and it tells us that this has undergone 4 half-lives. Okay, that's step 1. Step 2 is we're now going to find the mass remaining. So we look at our problem and we find our mass, and there's our mass right there in grams. We have 1 gram. Sometimes they're given in milligrams, but often in grams, or even kilograms sometimes. So we're going to take the mass, 1.0 grams, and we're going to multiply it by a value. Now the value that we're going to multiply it is 1/2, because every time this mass undergoes a half-life, it cuts the original mass by half. Now I'm going to use, instead of a half, I'm going to use 0.5. I just think it's easier to deal with decimals than fractions, but it means the same thing. Now I'm going to multiply it by its half-life, or the number of times it's undergone the number of half-lives. Now we look back up to number 1 and it says that we have undergone 4 half-lives. And so what I'm going to do then is I'm going to multiply 0.5 or multiply 1 gram by 0.5 4 times. And the reason why I multiply this guy 4 times is because this guy underwent 4 half-lives. That's why I'm multiplying it by 0.5 4 times. It's undergone 4 half-lives. It won't always be 4 half-lives. It just will be in this case. And then I'm going to, of course, use a calculator for this. And so the answer that I get is 0.0625 grams. And that's my final. That's how much of this 1 gram sample remains after we cut 1 gram in half, and then in half again, and then in half again, and then in half again, 4 times. Okay? So that is, that's an example. Now, in Google Classroom, you have a worksheet that I've given you, and I'm going to do a couple more problems off this worksheet for you, and you can follow along and then fill them in. Most likely, it's best to do this worksheet on a piece of paper because we're going to do some calculations and you have to show your work. Okay, so here is question number 2 from your worksheet, question number 2. And so let's take a look at this. So it says the half-life of radium-226 is 1,600 years. There's its half-life. How many grams of a 0.25 sample will remain after 4,800 years? Okay, there's some good information. So again, first step, we're going to determine how many half-lives it's gone through. And so we're going to take our time elapsed, which is 4,800 years, and we're going to divide it by its half-life, which is 1,600 years. Notice both of those are the same units, so they can cancel out. So we're going to do 4,800 divided by 1,600, and that tells me this guy has undergone 3 half-lives. 3 half-lives. Okay, that's step 1. Step number 2, we're going to identify our mass, and our mass is right there, 0.25. Oops, let me one too many zeros there. 0.25 grams, and we're going to multiply it again by a half, which I'm going to put 0.5. Now I want to multiply it by 0.5 3 times because it underwent 3 half-lives. Okay, this guy underwent 3 half-lives, so we multiply it by 0.5 3 times. Now another way to do this is to simplify it. You could just write 0.25 grams multiplied by 0.5 raised to the 3rd power. It gives you the same exact answer, 0.25. So it depends on how your calculator and how your calculator can process this. We'll call it 0.0313 grams is what I get. And that's my answer. Okay, now there's one last problem I want to highlight, and this is question number 5 from your worksheet. Question number 5. Now they're going to throw this something a little bit different, question number 5, so I want to address this right now. Okay, so it says the half-life of protactinium-234 is 6.75 hours. That's important. It says what percent of a sample given will remain after 27 hours? Now the first part of this is exactly the same. We're still going to find the number of half-lives. We're going to take the total time elapsed and divide it by its half-life. And this is 4 hours. Okay, now the second part is what's different in this problem is it doesn't give us a mass. There's no mass, but it does give us a percentage. What percentage? Now here's what we're going to do. The previous 2 problems we gave you, they gave us a starting mass, whether it be 5 grams, 10 grams, 0.25 grams, doesn't matter. We're going to assume that we're starting off with 100%. 100%. So what I'm going to do is instead of mass, I'm going to multiply this by, I'm going to start with 100, my 100%. And then I'm going to multiply, just like I did before, a half. I'm going to multiply 0.5, 0.5, and I need to multiply 0.5 4 times. So I'm going to do 0.5 times 0.5 times 0.5 times 0.5. Essentially, we're taking the 100%, we're cutting it in half once for 1 half-life. We're cutting it in half again for another half-life, cutting it in half again, and cutting it in half again for yet again. So we're going to take 100 multiplied by 0.5 4 times. And so I'm left with an answer of 6.25%. That's what remains after 4 half-lives. And so hopefully you can see the difference between a mass problem up here, where we're given grams, and a percent problem down here, where we're just given percentage and we're going to start with 100%, because that's all of it. Okay, and so that is a half-life problem, 2 different ways, and there'll be some practice problems for you to do.